Hello everybody, welcome to another stream. How are we doing? So last stream we did the parallel sort. We ported that code over from AMD into the code base. So it's all in here now, it all compiles. We've even got the GPU shaders and the CPU code that triggers the dispatches all written up. But when we give it a run, we've got a problem in my compiler. It's outputted incorrect SPIR-V for the Vulkan environment. So we've just got to quickly go and investigate what the crap that is. And then we're going to carry on and test out this parallel sorting algorithm on the GPU. And yeah. So it's saying that push constant ID 38 is missing block declaration. So I'm surprised we haven't needed this already. And I'm wondering what happens if I just let everything have block. Because when you read the spec for what block means, it just says that it's a memory interface, which I don't even know what that means. And I can't find any documentation to help me with knowing what that means. It says here, applies the structure type to establish it is a memory interface block. And then this was another one called buffer block, and this was deprecated. Just use block instead. So this may give us more information. Applying it to structure type to establish it is a memory interface block when the type is a uniform storage class. Distinct from variables decorated with block in all other storage classes, the declaration is meaningless. Right, so the problem is I'm thinking I'm gonna have trouble with trying to find the thing that is a... Well, no, I'm not. It just takes a bit of extra work. I just have to go over all of the entry points, get the parameter, which is the bundled constants, right, the push constants, and get the type for that, get a list of all of those, and then if it's in that list, then it should get that decorator. But I'm going to try and do something a little bit more lazy and just give every data structure that decorator and just see what happens and just see if we can go on with our day. Is it radix sorts? Yeah, so the AMD parallel sort is radix sort. It's a radix sort. Is block registers or LDS? It doesn't seem to map to any of those from my thinking. Because on AMD hardware, push constants sit in SGPRs, right? Scalar registers. They sit at the first N registers, basically. Depending on what your pipeline layout is, right? If your pipeline layout says, hey, I've got 32 bytes of push constants, then the first 8 VGPRs will be, because 8 times 4, right? 4 bytes per SGPR. Yeah, is a... Yeah, so I don't think this... It just is... It's bananas. I just think it's a load of bananas. I don't know what it actually maps to. It's just hard to see. Hard to tell. But if I take a look in the SPIR-V one, we already use block because we've had to put it down for these system values. So I guess it means that SGPRs or VGPRs, right? So it registers basically, right? Maybe. So I wonder what happens if I just did this. For every compound type, just add the decorate. See what happens. So apparently all the samples just compiled fine. But it doesn't mean they ran okay. So let's go into these samples. And we get a wet screen. So I guess not everything can be. Oh. Default. That's nothing to worry about. In the terminal, it's all about the get instance proc address. Dispatch create graphics pipelines. Right, 877. So it seems like it is causing us problems. App GPU Vulkan. Okay, yeah, creating the graphics pipelines. So if I were to put that back then hit compile, go to the samples and launch it, it runs. Alright. So it's something to do when I dereference, say, I'm dereferencing a pointer to that global variable, which is the push constants, and I'm loading that in. And it wants it to be this block type. It's because I put the dereference in for it. So maybe I need to look at that code and see, like, has it got the right... Here. It's difficult. Because you're just deduplicating a type, but it has got a storage class. Oh, I can just see if it's got the storage class push constant. We must hit that, right? That's only if it's a pointer. If it's not a pointer... I see. Needs block. Yeah, see, blocks don't seem to map to anything because it's going to be storage buffer or push constants. Which doesn't necessarily mean in memory or registers. Right, so I wonder, so when we did the deref, I wonder if we could pass in... So I reckon my push constants automatically have this block, but when we dereference it, it removes it. So if I were to grep, sorry, this BV disassemble, and I want to specifically look for one of those push constants, what we'll find is it probably has a block decorate on it. Yeah, they already have it here. So what's happening is, because I've done the dereference on it, the code that generates these data types Hmm. Okay. So because that is generating these data types is it's generating this one um, without block. Because the first time it does it. Wait, is the storage class bundled into the it's bundled into the key that you search for anyway. Okay, so when you do the load, so we'll be creating two different types. Right, I'm gonna add this in the sample code just so we can trigger it. Let's go to the triangle. So the problem is I'm dereferencing this thing. And that's causing issues. So if I am to run it now, what we'll see, this is the sample at all. This runs? Did it optimize what it was doing? Maybe SPIVy optimized it out. So let's find the unoptimized code. Scripts build. Let's remove the O. Optimize. Compile. Ah, still works. Interesting. Let's put that back. So why does that one work? Ah, because I'm passing it into a function. This is why. So let me do something like, right, triangle BC, wait. HCC read-only buffer triangle vertex, get vertices buffer, I don't know. We'll pass in just by value, and then that way terrible code. Oh, wait, what am I doing? All right. Oh, what is this? Resource descriptor load. Right. So you can't do this. This is problematic, maybe. Oh, we've had some more problems. Hey, Captain Chico. How's it going? Welcome to the stream. How you doing? Right, so that's an issue where from the return you try and access to an axis. I don't know why that'd be an issue. Right, excellent. So now we're able to reproduce the same problem. So I pick the samples up, and this is going to crash. So it means we've generated a binary now that we can inspect. Just wait for it to crash properly. Yeah, here it is. So push constant whatever is missing block. Why is that? So we hop into this SPIV disassembly. We're going to find that triangle BC, I think it's called. So this is the strut. Here, the push constants that we upload from the CPU. So we upload like tint and then some buffers, right? But this should be marked with push constant because it uses push constants here. So when we dereference it though, the whole thing, it doesn't get assigned that type. So I wonder if there is either two of them that is there, or if there's just one. So we need to see if there's two data types or just one. So we're going to inspect for that. So here's a strut. Has it? Well, actually no. Right. So the variable's been marked with push constant, but the data type itself hasn't got the decorate. It's because we've used this. We've marked this before. This is by value. It does a deduplication on this type or something. Right. I see the problem. Working on some ARM64 page allocators. Nice. You didn't like a custom OS, operating system, or like a ARM for the ARM architecture. So here's the SPIV type to duplicate storage class data type. It comes in as a pointer. Okay, sorry. This one comes in by value, right? I'm still confused. Ah, it's because it's not a pointer. This gets overwritten. And then the key changes. Right, that's interesting. So I guess we want to say if it needs block. I don't know, I think push constant. And not push constant. Because push constant needs the block to be there. I think that was the issue. Right, let's give that. Oh, you bugger. Duplicate? How did that make a duplicate? Um, how did that make a vector type to them? Let me just go and correct my boy. His brain a wobbler when he's trying to sleep. Says moves around. 2 seconds. Right, welcome back. So why did that end up creating duplicate types for vector types? Because vector types never get push constant. But that's also something to think about. Hmm. See, I wonder if we should add the decorate in a different way for a push constant in the compiler. Wait, where's the other code? Oh, it's after all that, right. So it's compound, put the block thing on it. Yeah. If it needs a block. Or if it's one of these guys. Maybe what we do is we just have a list of all of the data types. And we go over those first in the generation step. Well, not first, but last. But that means the pointers to them will also need it. But yeah, I don't know why this created that code. Where are the vector types made? They're made in SPIRV link, right? They're literally just hard-coded here. So there must be some invalid thing, perhaps? SPIRV op type vector. Oh. Oh no, sorry, those are the Boolean ones, which should have been deleted, actually. Oh no, those might need to exist as intermediate types. Right. Right. So you want to say if this is a strut. Booleans, Boolean logic. So we want to say not strut, but maybe compound. So so if the data type is not a pointer and it has a storage class of push constant and it's not a strut with a storage class of push constant. But then I think that would just create a duplicate strut definition now. Does not match. Argument found 54 does not match function ID type parameter. Yeah, because they're different. It's got two different strut definitions now in the binary. So that's problematic also. So I guess if we come across, so I guess we just have to have a way to add the decorate onto it. Okay, that's possible. So I think what we want to do, but how do you know? Oh, man. Hmm. So you can need save you need a block because it's a push constant, and it comes around a second time, or maybe it says it's not new. And then we say if it's a compound and needs a if compound and need block, then chuck the block, add the decorate onto it or something like that. Right. Let's give some of this a go. So HCC Spear V operand? I think that's what that needs to be. Operand. There we go. So we're gonna probably have duplicate decorations, right? In the binary, but that should be okay, I think. But Spiffy usually doesn't like duplicate stuff. So, but I've not seen a rule for this one specifically, so we're about to find out. So, right, that appears to have compiled. Let's run the sample. Damn it. Another problem now. Now it's seg fault. Compiling the graphics pipeline. What's up with that? What is up with that? There's just BV diss on the shaders that we made. We want to look for that triangle BC again. Oh, for crying out loud. Okay, so they exist here. Is there any sort of there's decorate block? There's two decorate blocks now, right? Which is probably problematic. So we only need one, right? So what I'm gonna do is I'm gonna write a bit of code which is specifically hard coded for this thing, where I'm gonna say, okay, static int ttt equals 0, right, and ttt equals 0. Then we'll up this by 1 or set it to 1 or whatever. So this only gets triggered once. So now we're going to tell if having just one of them in there fixes the problem, it's not something else. And then if so, we'll add a quick and dirty hash table in there that will just keep track if the thing has got the decorate already for block, and then just only add it in if it's needed. But I guess it's just silly stuff you have to do. Okay. Come on. What else changed in the binary? Since... So we do a dereference. Oh no, so it's the error that we was supposed to have fixed. Whoops, this wasn't the one with a need block. Okay, so I just did it for any old data type, right, okay. Does this fix it? Okay, good. So it does fix it. Nice. So we're just gonna whack in a super dirty thing now, which keeps track of whether or not this has already been done. So I gotta find somewhere in the SPIR-V. I think it's in the internals, the SPIR-V sort of like section. Right. There's some hash tables. So what I want is probably, have I got like a hash set? I don't have a hash set in this code base. But maybe, oh no, maybe you can just use the thing as a hash set. But yeah, we basically just want like an array or something. Or I could just store it in the entry. I could just be like, has this thing got the block decorate? I need 1 bit. It can't go in the key, that's the problem. And it can't go here because it's atomic. Let's just add a boolean. It's gonna add 4 bytes, but oh well. Right, has block decorate. So let's see if this buggers anything up. So basically we got our entry. We grab that from the table. If it's new, excuse me. So if it's new, where do we do the stores here and return boolean? No. Add the type. The store happens there, excellent. So that means we can put it here. Entry has decorate equal true, right? So I've just whacked it in there. Bear in mind it should probably have whacked false in there at the entry point. Sorry, the entry of that if statement. And then we want to look at that boolean here where we're going to say hey and make sure that this is not equal to true before we can add another one in there. And it should be as easy as that. Should hopefully be the fix. Oh, we didn't put true in there. We need to make sure that we set this thing to true. We got another crash in the driver again. And I could have swore That's right. Triangle BC. Does it have that block? Right, it's one block right there. Huh? I wonder if there's multiple things with this decorate. Dot star block maybe. Does that work? Good. So see if we see any duplicates. Vertex has got block. Right, they all seem pretty one and done. Yeah. Why is it crashing then? We just saw... So I guess what we can do is... Um... Um... I wonder what we can do. So if we just say... Um... So it has block decorate. Yeah, if we revert back some of the changes to... Let's see if adding this field was the problem. And let's see if we can get it to boot. And then we'll take a diff between the two. CP shaders dot spivvy to shaders dot spivvy dot back. Right, so that's copied now. So I think what we can do is we can see what spivvy will generate if I do something like this instead. And init equals 0. And just compare those. So first of all, I check does it boot? And the answer is yes. So now I do the kind of like a diff between shaders.spivvy and shaders.spivvy.back. So they differ. So now we... Can you pipe stuff into diff? Well, there's an easier way to do it. We can just generate the things that we want. So I'm going to pipe that into 1.txt, and then I'll pipe the backup one into 2.txt, and then I'll do a diff on those two. Right, there's only a handful of things. Oh no, there isn't. Crying out loud. Right, so we've got to go to the top, because that's where the meat and potatoes is. Right, so one of them contains. So the difference is from here. The rest of them come from just the IDs being offset because it's got these extra bits in it, I think. The code gen afterwards is just, yeah. I think it's because of this. Yeah, and the bounds are a little bit different. So I think it's because it's missing block. I'll be missing block. Let's look for this one, triangle vertex, in the new one. Spivvy diff. Triangle vertex. Right, it doesn't have that block specifier. It just doesn't have it. So why did it get removed with Oh no, it got removed and it ran fine. What am I cooking? That I do. So in the last stream we made a compiler bug by dereferencing the push constants. So we pulled out a whole. So we're pulling the AMD parallel sort code, which is it's a parallel sort, and basically we dereference this guy and pass it into a function, and the code gen is just a little bit wrong that it just falls over, and it feels like it's something very. I can't understand what the low level mapping is to this thing, but we've essentially got to put this flag. Yeah, we've essentially got to put one of these block flags on the push constant data type, and it wasn't going on there because I was making a function with the push constant structure, and it wasn't coming from like a one with a pointer that we know is push constant because it's part of an entry point of a shader, so it wasn't getting the block flag basically on the type. So I'm trying to sort of have a way to add it on ad hoc, right? But that is, yeah. So I think I'm nearly there, but it's just a bit of a bugger. Audio on Linux, everybody. But yeah, and then we get back to testing out the sorting algorithm. What do you think about parallel? What do you think about parallel execution in C++? I have no idea. I have no idea what that even is. I've not seen it. All I can say is like C++ probably has enough things. It probably doesn't need that, and it's probably templated like crazy. But yeah. So right, let's figure out this problem. So it did when I did this sort of like it is. So I did this version here where it only adds one block decorate on. And then that one runs fine. Okay. So I did this sort of hack where it only adds one of these block decorates on ad hoc, right, when it's already found the type. But it seems like it's a bit too liberal at it, I think. Um, let's figure out what this diff thing is doing. So I'm diffing 1 and 2. Okay, so arrow left is left and arrow right is right. So old and new, I guess. Let me just man diff again. Files. Yeah, but I guess that's what it means. So they're kind of like. There is a side by side. There's a dash y. There's a dash y. The bound is different, they were saying that, but I can't figure out, like... Oh, so then it added... Right, what was 2 again? So 2 is the old one. Right, okay, so... When I'm looking at the differences here, the old one added block to these things. The triangle vertex, voxel model, and SDF shape. This is an accident waiting to happen, probably. And we're just making it more. Right, so I'm only really want to do this if... This only didn't happen because why? So it's adding, because it's like a storage buffer element type or something, it's adding it in ad hoc. Right. But if it's not a pointer, so which ones, what decorates do we have in here? Let's do this on that. Which decorates have block? Just the push constants and the actual storage buffers. Why has that got one there? Getting away okay with it. Oh no, that's push constants. Okay. So effectively these have to be for pointer types, but only needs block if it's push constant and not a pointer. Nowadays. Okay. And is not pointer, I think, or maybe it's for both, but the rest, all of these guys want it to be a pointer type of some kind. Now these SPIVy rules, I do not understand what they map to in a low level, and it is bananas. Right, so if we go down to this sort of block thing again, let's remove these silly safeguards, which we'll put in as a way to hard code. Right, so it's equal to false. Put a block on there for me, please. So apparently compiled fine. There we go, success. Alright, so now we can move on out of this sample thing. So now we've fixed the bug, basically. That was crazy. But anyway, so hopefully you guys have seen how crazy SpearV is. It's cool and everything, but it's just super restrictive and annoying. It wants these sort of like, it has these artificial things it's made up, and you don't really know what they map to in a low level. So you're just left with hammering your head against the wall until you solve the problem, and then forgetting about it and just enjoying life programming in C for shaders. So there we go. So now we can see if our parallel sort actually works. So something I wanted to double check before I... No. It's alright, it's not plugged in anyway. So let's give it a run. Excellent. So this is where we're at before. It's still not sorted though yet. So I've got my UI plugged in again. This is the old BVH viewer UI, which should just be gone really. Maybe we should just get rid of this for a second. This is our single instance model, which is made up of tons of spheres. We're trying to... It's being occluded, kinda. Sorry. It's being occlusion cold. These textures here are the occlusion buffer. It's basically a copy of the depth buffer from the previous frame with no changes whatsoever. But we're getting these flickers here. So I think part of the problem is, right, hands off, we're getting flickers, is that it may be, I want to remove part of the problem where we're getting this sort of cyclical thing where the depth buffer from the previous frame is feeding into the, because you're seeing it flicker in the occlusion texture at the back as well. It flickers there. So I'm thinking that maybe it's caused by that cyclical nature, and there's a maybe sorry. No, there's a bug that's happening in... Yeah, I want to know if the bug is happening because it's the depth buffer or if it's in the occlusion culling code itself, basically. So I'm going to get some fixed occluders in, and we're going to have a bit of a play with that and see if there's any flickering still. And just try and figure out the problem is. So we've got these fixed occluders. Wait, maybe that's what the problem actually is those occluders being rendered into there. I've not disabled that yet. But yeah, so I'll show you the occluders. When we generate the volume, we generate the best occluders for that volume. So it's not the volume instance, right? It's the volume itself. We construct it. We construct every frame at the moment, just because I want to catch all these deterministic problems. So if we open up the graphics CPU side, what we're going to do is we'll probably just write some UI quickly so we can toggle all of these options, which would be pretty cool. So let's find where we've got this sort of parent button and all of that. Here is our sort of temporary debug UI thing. So we'll just, we're going to do a new one. So I think what I want to do is just create a bunch of, I want to create some things that will be useful. So this one is going to be occlusion buffer, reproject depth. We can default this to whatever we want. Occlusion buffer The other one is like occluders, isn't it? Occluders, yeah, whether we want those on or off. So we can toggle those. What other good options would it be to have in this? So those would just be some checkboxes, basically. So we'll just get those boys in. We'll do a checkbox with some text. And a checkbox with some text. Gotta figure this one out. Right, rectangle is checked, string style. Cool. So a rectangle, the boolean, the string. So this is basically reproject depth from last frame. Then we want the style. So I think I'll just pass in the box style and voila. So that will be able to be toggled there. And we'll do another one. And this will be occluders. So now we should be able to toggle some options and see. Oh, damn, it wants one of those, damn. There we go, C strings. Here we go. Do you have your own BVH tree implementation? I did. We're gonna do another one again, but I added an LOD system, and so the old one is now redundant. But it now doesn't work, and I want to do a version 2 of it, which would be way better, and hopefully much better performance as well. So basically, I added an LOD system and way more spheres. Right. Get rid of this boy. Cool. What is next? So now we got those. I want to enable this one by default. So we now need to get this plugged in. So where do we do the occlusion stuff? So this is the reproject from last frame. So we can just put the if statement here, simply. If reproject last frame, it will do that there. So that puts into the buffer. The clear, the clear should just happen here, so I don't have to change this thing. Just clear the whole thing. Maybe technically I can just say, yeah, bit of fun. So saying it's going to start from 0 or 1, depending if that is true or false, basically. Right. So where's the occluders? They're here. So these will ray trace the occluders in the occlusion buffer. Right. And then we do the propagation stuff. And then we debug render the MIP levels. So that's what's doing it, putting it on the screen. So if we give this a run now, voila. So we should be seeing the occluders on screen. We're not seeing them. These are some big checkboxes. But yeah, so I need some buttons where I can just sort of like, I need to be able to press escape and stop the, like, freeze the camera and untrap the mouse. That'd be something decent. Right. So I think what I want to do is just stick something somewhere, like here, I guess. Static boolean. Like we want to like move the like trap mouse, I guess. Right. It's automatically trapped by default. Because outside of the code, this is super hacky. So in the main loop, it sets the main function. It sets that up as being trapped. But we can just change it here. So if we press the escape key, so if OS key code has been pressed, probably the virtual keyboard actually has been pressed. Key code. We'll do an OS key code of escape. So if that gets pressed, then I want to toggle this thing. Whoops. I want to toggle that. Then I want to say, okay, if trap mouse, else, then I want to say OS mouse hide. I think it's called a show or hide. I don't even know anymore. Virtual mouse. Yeah, hide. Or as we show. So that's step one. One allowed me to go out of the window just by pressing escape. And two, we only want to update the view from world if we have not trapped the mouse. I think that's a sensible idea. So this needs to become an if statement. Oh, I put that in the wrong place. Yeah. So if we haven't trapped the mouse, oh no, if we have the mouse trapped, we'll allow the movement of the camera and everything. So essentially it's like a pause screen, I guess, if you will. Let's just try that. So if I press the escape key now, right, it's reset that back to the beginning. You know, I can click these a bit easier and doesn't move the camera. That's alright. Have I tried Odin yet? I've seen it over the years. I've not downloaded it and given it a go. I've just like seen it and read a lot about it really. But yeah, I did a lot of Rust for programmed in Rust for 4 years, from about 0.8 to about 1.3, something like that. Yeah, I've had my taste of newer languages basically. Yeah, it's not my cup of tea really. Yeah, C must live on. It's just there's just so many little things about it where it's just embedded into everything now. But also, the more I just program in it, the more I just feel like it just solves so many things elegantly. There are obviously some problems with the language; it's not perfect. Um, but newer languages just don't solve some like some the problems that C already has solved elegantly. But yeah. Well, I did that it's really trying to stay true to C, but removes the warts. Yeah, it does look nice. I do admit, I do prefer it to something like Rust or Zig probably, but still, yeah. Other languages have good reasons to exist, but it's better to keep the lowest level libs in CFFI. Yeah, it'd be nice if there was a different way to communicate for the newer languages, other than C though. But yeah, it's the thing to communicate. We have a lot of experimental alternatives, both for kids. who don't want the legacy, and for people like me who are sick of the same wars for 20 years. Yep. I'm not sure what's, but Zig. I don't know. Every time I look at Zig, it doesn't look like C to me. It looks like some. It looks so like going towards more C++, like all that meta programming stuff and that. Like it's just like you get when you give people so much power, what they do with that power is just crazy. Like you just don't need like templates and that all you need is a good macro system, right? And sure, it might feel a bit ugly trying to use it to do templates or whatever, but that's the point. You don't want people to make templates for everything, because if not, before you know it, your whole standard library is templates, and every structure you use basically is a template or generics, whatever word you want to use, and it's just crazy land. Uh, so yeah, templates. Everything is templates now. From my point of view, oh no, really. From anything that can use CFFI and theoretically transpile to C should be fine. Yeah. I wish Rust had a transpile to C option from the start. Yeah, that would be good. It means it's more portable that way. There's no templates in Zig. They do something different. Yeah, they have comp time, right? But still, templates, right? Ginger Bill for Odin said that basically wants to improve C, not replace. Yeah. Yeah. You learn to love hate the preprocessor. Like, there's some problems it just solves. It just solves well. Like, if you look at Rust and how you try and solve a conditional function, like, if you have two functions with the same name or whatever, like, you want to say, like, if this function is part of whatever, you have to say, like, config, and then you've got essentially you got this sort of like other language here, which you can argue is so is the preprocessor. But it's like, you know, and then this thing just gets like bananas, and you've got like one on every single function that you've got. Um, and I guess you can do a whole module and then probably include the module or something like that. But sometimes the if-def is just kind of elegant at solving that problem, you know. Only some very restricted compile time statements when using one. Right. Okay. Yeah, the compile time stuff just feels like it can be heavily abused and people will abuse it like crazy. In code base like in code bases, you know, they get big or compile time stuff everywhere just makes it all slow. Mm. Yeah, I've seen C3 as well. Mm. Is forming a new vertex buffer like AABBB better than ABB? It depends. So yeah, you're talking about having two different vertex buffers, isn't it? Oh no, using the vertex streams or something like that. Uh, so it just means that you can update one portion of your data separately, right? Like, yeah, it basically doesn't matter. It's just, it basically just like, it depends on how you want to um, update your vertex buffer. If you have all of your BBBBs in a row, then it means you can simply upload to that array and just change that data. Say this is your say if this is your positional data, and then your AAAs are the texture coordinates, which is just a bit weird way around to do it, but then you can only update positional data and the texture coordinates stay the same, type of thing. But yeah, I would go as far and just say don't use vertex buffers because they're just an extra abstraction. You can just use a storage buffer instead. That's what we do. Well, we didn't use vertex buffers in this project, but yeah, that's what I'd do if I didn't. Because you just have to declare their type and everything in the abstraction. But storage buffers are just fine nowadays. Right, I want to disable the updating of the view from world. That's what I want to do. So why am I setting it to identity every time? Good point. That should happen once in here, in the initialize. Awesome. Yeah, it's just another way to make the rendering abstraction simpler, because it's so easy to have overcomplicated rendering code. But yeah, on like AMD hardware, the vertex buffer doesn't, like, they just insert instructions that decode from the vertex buffer. I think NVIDIA's a little bit more, does a little bit more like, sorry, let me just say that properly. I think on AMD hardware, when the driver compiles the shader, it inserts like instructions that pull the data out from the vertex buffer, and then it at the start of the shader, the vertex shader. So it's you're not really getting anything for free there, right? It's just the same. And it does the conversion in the shader as well. I'm not sure about NVIDIA, but it's probably quite negligible nowadays. Same with like a constant buffer or one of these like buffers, right? Because yeah, GPs are just different now. Storage buffers are probably just fine. Yeah, I wanted to. Oh yeah. So if I press escape now, oh my days, get out of there. Oh, for crying out loud. So I still want to. What is resetting this? So reset to identity transform there. Did I just not recompile it? Yeah, good. Right, it's gonna recompile. So now I got this mouse and go out the screen. Yay. If I just press escape. Nice. Alright. That's good. So now I can do these things, toggle on those bits and bobs. So where are my occluders? Why don't I see them? Good question. So we need a way to you know what, we need a way to yeah, where's the in the shaders when we do that sort code? This is the old sort function that I made. No, make persistent here. So this is when we copy the volume to persistent memory, or we begin to at least. I go and go over all those occluders and debug draw everything. So this is, I don't know what I did there, but it's a bit. Anyway, let's restart that. Okay, good. So this is just doing it as 00 origin. So it's this object here, but yeah, different scale as well. So this is what we're trying to fix as well. Is this this is not deterministic. We're making it every frame, and it just changes. So the occluders exist, but why don't I see them in there? Do I know they exist? Be looking at these a bit more later on. Ray trace. Occluders. Right, we'll get closer to the screen and see if they. You know, I had that debug code in the ray tracer. I guess this is it. The sphere ray tracer. No. Yeah. So the bottom of this guy. This is the one of the last full screen passes. So I just chucked some bits at the end. This one renders the occlusion texture. And it says if it's not infinity, I put something in there. So that's one. What is going on? I think this is a call for render doc now, because I'm a bit confused on why I'm not seeing the occluders in there anymore. And then we can sort the occluders properly with the new AMD sort. Alright, so hop that in there, and we'll just find the... Right, somewhere here. Clear, 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 clear. Ray tracer. Bam. It's not doing anything? State. Volume instances. Render dog. Hey, Meeple one. Yeah, it's pretty good tool. Pretty good. I was tempted to get one of those AMD APUs, 8700Gs for some variation. I only have NVIDIA GPU. Yeah. So the NVIDIA, if you're running on Linux, the best driver quality is Intel and probably NVIDIA. AMD is open source, so it installs on your system really nice, but it just brings down your whole desktop when it crashes. But yeah, it's good to have a different. It's yeah, it's good to test out your code base on different hardware, because when I test on my Intel laptop, it just falls over sometimes, and I have to fix the bug. So if you're running a lot of shader heavy code, it's good to test it all out on different hardware. Those CPUs are godsend if you want a tiny enclosure. Yeah, yeah, the APUs are quite nice, I guess, because the graphics is much better than the Intel ones, and they're sort of low powered and they're like on laptops or Or I was just saying small PCs. Yeah, so I was thinking a little ITX for mini PC. Sweet. Yeah, I've got a small build, but I've got a GPU in it. I got one of those sort of wait, what have I got? I think I got an ITX. I forgot these things. But it's basically half the size of a big PC. It's like, yeah, it's pretty neat. But yeah, I built it a couple years ago now. And thanks to Meatball1, he also donated some money. I remember that. That was really nice of you. On the other hand, you can fit a mid-tower everywhere, can't you? My PC takes up half a square meter. Yeah, it's so bad. My work PC is bloody huge, man. It's like, it's ginormous. It's just funny how mine compares to it. I mean, it's fun. Well, I've got so many pictures of my baby now. It's just scroll past all of those to the time before the baby. That's what happens. My phone used to just be accidental pictures of screenshotting my something on my phone. There is my PC. There it is. Gotcha. Right, see if you can see an infinite version of it. It's like a mini. So yeah, it's like a square across the X and Z axis, I guess, and then it's like twice that size on the Y, if you will. It's pretty neat. Probably just anyway. It's got the CPU. Ah, got the CPU. Damn these things. CPU then a GPU alongside it. And the cables go around the back. It was pretty neat. I'm very proud of myself. It is all spread out on the desk. Oh. Yeah, that's me building it. Yeah, I have a baby now. He's asleep. I got him on the monitor. Got a little baby. Still not crawling yet. Ray tracer for occluders. Occluder ray tracer. Grr. Alright, finally I got to it. Right, so this just goes over all the occluders. Right. But I commented out the line of code which does the right. Past me. Past me is like just confusing me now. Here it is. Right, so as you can see in the lovely occlusion texture, here's the occluders being written into. Right. Okay, nice. Toggle it on and off. Cool. So these are obviously not playing into this, right? But yeah, another thing as well is they're probably not near the edge, so we're not seeing some of the artifacts maybe, but we're seeing it. Oh, that's a bit weird. No, that's probably alright. Yeah, I need to. Anyway, we're here to do the sorting algorithm. I can understand it not hiding what you want to hide. But why is it flickering? Yeah. Yeah, I don't know what the problem is. But I feel like we've probably answered our question already. Like, I know why this one's flickering. This is because I'm rebuilding this volume every frame. I don't know why this whole thing is flickering also. Without any of the occlusion stuff. The whole thing is kind of flickering a bit. Shoot. I don't know if that's with the occlusion stuff on either. Yeah, the whole thing kind of flickers a bit as well. It's a bit weird. It might be, oh, you know, it might be. Huh. It could be to do with the sphere ray tracer itself. So the sphere ray tracer does some anti-aliasing thing, but it's kind of broken right now. Ah, that's what it is. The spheres are not ordered or something like this. Yeah. Right, we can fix this with our sorting algorithm, but not what we're about to plug in, which is to fix this from flickering. So I think what's happening is the order in which that the spheres get rendered. Also, that makes that flicker that. Oh no, of course, because that's flickering. But so I think what's happening is the spheres when they get tiled bend into a screen tile. Either I think they're just in a different order, and the anti-aliasing is wrong because they are meant to be from front to back, but it's not sorted front to back, and that's why another reason why I got this sorting algorithm plugged in. Ported over, so we can plug it into when we do the tile bending. We can sort the spheres from front to back. So that is going to be a big help. But I want to test out on this occluders first because this is a very small amount of data that I can test out on, and then we can do a better. That'll be the next thing that we do after this. Can I try your code? Wait, is it a randomized algorithm or something? So weird. Oh, it's a parallelized algorithm. Yeah. So it's done on GPU. Everything is out of order. Like the order it dispatches compute shaders is unordered. So it could be in any order, and it changes every frame. So yeah. Can I try your code? Why is it Linux? I haven't had a coffee all day. Why am I so hyper? Yeah. If you're a sub or something, you can get access to the code on the Discord. A sub via Ko-Fi or Twitch, any of those, and then you can get it on Windows and Linux. I try to keep a build. I try and only commit when there's a build that runs. So I do a feature on stream when it fully runs and I get it back up and running again. I commit the code and get it working on Linux and Windows. Yeah, Windows comes second, unfortunately, because I can't do two things at once. But yeah, so I'll put a link in the chat. Anyways, follow link there. It is very okay. I wish you the best of luck. Thank you. So what do we want to do now? We want to sort those occluders using that new lovely sorting algorithm, not our terrible one. So we've got GFX sort, which is for non-indirect stuff. This is the port of the AMD thing. I wanted to double check something actually. How do they do that loop again? Right, so it is that. Right, that's fine. So, oh man, it's just weird. Perhaps switch around. Okay. So we've got this one here, which requires that you know the amount of entries that you want to sort. And then I've got an indirect version, which allows you to have this sort of like sort entries count in a buffer somewhere that the GPU populates, and then you will set that on the GPU side. So I want to try out both. I want to see how they work. So we're going to start off with the non-indirect version. So we go to where we have a kind of sort. Here it is, this guy. This one has been nuked from orbit, just taken out. So I need to, and I want to replace it with this. So sort occluders, it gets it from, right. We might need to make a parallel array, but I want to just get rid of this code. Okay. So, having been nuked from orbit, we can... Okay. So there's an array of volume constructor occluders, and it makes those... It makes like it gets 1,000 of them or whatever. Of the occluders or whatever, right? And it pushes those. So this will be our payload, I think. Yeah, we have to pack this down into a single U32, if not, it's not going to work. Oh, I'm going to have to change how this works, damn it. Right. So these are going to be that's our payload, and we need our sort keys as well. We need to sort based on how big it is. Or will we only need one? This has to be a U32. LOD 3 bits. Cluster chord. Sphere chord min and max. Yeah, so we put the LOD in the high bits. Then that'll be sorted first, right? Then the cluster chord next to that. Yeah. I think this should be alright. I just gotta do the actual packing code. So what is the key for sorting a U32? Yes, a single U32. Yeah, it's just a U32. No. Resource ID is a U32. It's just a resource. In the high bits is a counter, and then the low bits is the index, and we have a pool, like an object pool system for it. But then we take the index part and we give that to the GPU, and then the GPU just looks up into the descriptor set and grabs the texture from there. Reduce the bit depth. I'm not sure what you mean by that. But I need to wrap this occluder so it's a 32-bit integer. So I guess we'll just say volume occluder. We need an LOD. We need a cluster coordinate. We then need, well, we can just ask for the sphere, like the actual sphere. Oh, no. Yeah, maybe a specific cluster and then the min and max within there or something. So it's just going to get packed. So we're packing the LED in the higher bits, so we need 3 bits there. So it's just and 3 bits, that'd be a 7. Yep. And then we'll shift it. Well, no, I much prefer the other way around. So we shift it up first. Yeah, we need to put these in the higher bits. So day 1 will get you. Yeah, so day 2 will take you all the way off the end. 1, 2, 3. And then we and the final bit. So that'll just be E. 1 byte, 2 byte, 3 byte, 4 byte. Okay, so there's the LED in there. Cluster coordinate. Oh, sorry, raw. Cluster coord.x. We only need 5 bits. Yeah, so 1, 2, 3. Wait, sorry. Let's do the 1, 2, 3, 4, 5. So that'd be 1 F. Then Y. Then Z. So it'd be 5 decrement, 5 decrement. So 5 bits. So it'd be your, these would be 0, 0, F, then 8, then 0, 0, 0, 7, C. Then colluder. I just need to do the sphere min and max. So those are a bunch of 2 bits. F8. Yeah, what about the F8? Did I mess something up? I need 2 bits now. So let's take these all down to 13. I need 2 bits each. Okay, excellent. Yep. So that'd be 9, that would be at 7. So that would then mean these are... Okay, so C, we've got 2 bits left, which is a 3. So 3, then we need C again, and then 3 there. Excellent. So that will then mean they are sphere coord min, min, min. I have written 1 shift of 23 to match the... Right. Yeah, I just prefer to write the whole hex because I just like to know that, hey, this, I like to know, like, I like to be able to read this and be like, oh, it's in those specific bits there, basically. I guess. Yeah, maybe you could tell it from these, really. And maybe that's enough, but... Yeah. Oh, well. Yeah. Maybe the shift is just enough. And you can just count the number of bits. Yeah, maybe that's not so bad actually. You can end it before and then just shift it up. So it'll just be like a you need 3 bits, it's 7. And then you need I need to change that one still, I think. Oh, maybe that is wrong. Let's have a look. Yeah, we'll do the rewrite. We need 5 bits. 5 bits is 1F. Still. So these are a bunch of 1Fers. These are a bunch of 2s. They're 2 bits, so they're 3s. Then, right, that'll be good. So let's redo that. Right, so you got 2 bits. Yes, you got 3 bits there. 5 bits. Take away 5. Take away 5. Take away 2, because we've got 2 bits. 2 more bits. 2 bits. So sweet. Then max. So from 7, so it'd be 5, 3, 1. So they got a bit left. I think there's 1 bit left. So we've got 6 2s, so we've got 12. We've got 3 5s, which is 15. So that's already 27. Then plus 3. Huh? Something's up. Ah, there's my extra one. Thank you. So if I put that's 29, let's do take away 5. Ah, there we go. Yeah, so if I up them all. Sweet. Thank you, sir. Right, so then I can just pull those boys out when I need them. I've not needed them just... Yeah. Right. We'll do that when we actually need to do the rendering code again. So... Okay. Now let's fill these occluders in properly. And we'll fire the sort code off, and then we'll bother trying to pull these out. So, if we find where we populate those occluders, why is it in make persistent? Make occluders. Where else had the occluders? What else? Oh, make occluders. Whoops, I deleted the wrong one. Oh, okay, no, I deleted it, don't worry. Yeah, I shouldn't delete this. It was reused in 2 shaders. Okay, so make occluders uses this. It's somewhere here. Excellent. So here's where we make the occluder. Now this cluster chord is actually not the one that we want. It's such a... Shift left, position to highest LOD. Right. So we've got 5 bits each, which means that goes up to 32, right? Yeah, it does a 32 cubed area. So we've got 128 cubed volume. So our cluster is a 4x4x4, meaning if you divide 128 by 4, it's 32. So in this 128, where is it? Yeah, in this 128 cubed area of spheres, there's actually a 32 cubed area of clusters. So that's why we packed it down to 5 bits. So this cluster coordinate, these variable names, what we need to do, so first of all we need to poke this in to volume occluder. Good. So put the LOD in there, cluster LOD. Now what we need to do is we need to actually make this be that sort of like, so we shift it, so we take the position, that is it in, when we're talking about this number of spheres, we need to sort of like divide it by 4 probably. Yeah. Times 3, divide that by 4. And then that'll be the one that we pass into here instead. So that will take, so this gives you the cluster's position in kind of like sphere coordinates, but not cluster coordinates. So this number could be, for instance, from 0 to 127 on the highest level of detail. But on the highest level of detail, the cluster coordinate in the number of clusters is from 0 to 31. That's what we need to do there. Oh, why can't I? Why can't I find that occluder anymore? Oh, it's in that header file. Sure. Sphere coordinate min. So within the cluster, what is the sphere coordinate? So you got the cluster position, min max. Oh, okay, that'll just be 0. We've not done sub. Maybe we'll just do whole clusters. I don't know, but we've not done sub ones yet. I think we'll do inclusive range because it's like a min max. There you go. Right, that wasn't too difficult. Sweet. So now in the ray tracer, we've got to change it, but then also in this. Yeah, let's just get it ray tracing actually, and then we'll worry about sorting it. Plug in the sort in. So we need to write the extraction code now. So the extraction code is going to be like, hey, on the LED, you pass in the occluder. And you get the LED back. So that would just be a return occluder shift right 29. It's just the inverse of what we've got above, right? And 7. I've got to do a dot raw. Alright. Static inline. Not that it doesn't matter actually, but anyway. The next one is a cluster coordinate. We could just get it to give us like what do I actually need? In the ray tracer, I just needed a center position. I need a center position and a half dims. Hey. Been a bit fiddly for a while, but eventually, yeah. But for the first hour, he was sort of rolling around a lot. Be quiet though. Yeah. Hmm. Oh yeah, the whole thing. No problem there. So about the occluders in the ray tracer. Okay, so we need the center position in local space and half dims in local space. That's what we're working towards. So I need when I have all of these different parameters, is there a way so I can get the top left of the cluster easily with this? So if I ask for the cluster coordinate, you know what, I might just divide it by 4 and pack it myself. Yeah, where's that div 4 thing? So instead we should rename it to cluster coordinate LED. And that will be easier to understand. And then we'll have this sort of other one, which is just going to be called cluster coordinate here at least, which is going to do the division div s. All right. Sorry, 4. All right. Oh, excuse me. How many of these thingies are there to be packed into a U32? We've got about 4 thingies right now. But yeah, we just have 1 U32 per occluder. And if we can't pack stuff into U32, it's just going to have to be an integer. Sorry, an index to some larger pool of data. I mean, how many times will volume occluder be called during a frame? So only when you construct the volume, make occluder gets called. So there's only once when the volume gets constructed. Then it gets sorted, and then per frame after that, it would just be reading, unpacking. Yeah. So afterwards, it's just unpacking. So basically, the rule of thumb is if you do packing, if you're packing to then unpack once, there's no point. There's absolutely no point in doing it. If you're packing to unpack multiple times, then there's a win in performance, basically. That's just the rule. Well, that's what I've discovered by doing personal benchmarks. That's a rule I've made up for myself, basically. Um, yeah, because it takes time to decode. Yeah, but anyway, we need to pack it also for sorting things as well. Sorting reasons. So I should be able to fetch out the cluster coordinate, and that would then just be getting these boys. Oh, and the music's gone. What a shame. Register to register ops are much faster than memory access. Yes. Yeah, exactly. That's right. So we want to put that into we want to do a multiply s e32 times 3. We want to then make this into a vector of integers. And then we want to multiply that by 4. Then return that. Oh yeah. So then the other one we want is a half dim. So, oh wait. That's at LOD. Yeah, that's at the level of detail, which then means we should really shift it as well. So, coord. Then we want to shift it, bit shift left, e32 times 3. I want to shift coordinate by LOD. I think that's right, I've done that in the past. Oh, to highest LOD. Yeah, to highest LOD. Right. Now that's at highest LOD. Well, we should have shifted it. Sorry, we should have also done coord equal multiply by 4 and then shift and voila. I think that's the way we want to roll. With a scalar. Boom. So that's one of the functions we need. And we also then need what is the half dim? Of the thing. Where's the Cluder's ray tracer? This one half dims in local space. Right. So I'd need that in spheres. How many half spheres is it? So you can get that based on the min-max, take the diff between those and then scale it by the cluster LOD. think. Yeah, min max plus 1, something like that. So you essentially want to do this, but with, do you want like a min and max? Your mins and maxes are, or do the min, let's do 1. So the min starts off at 12, then 10, then 8. And there are a bunch of 3s to AND by. So that gets you from 0 to 3. Yeah, bit twiddling. Nice name. So this will be your min from 0 to 3 inclusively. Then the max is simply from 6 I forgot to say unused 2 bits. But yeah. So 6, then 4, then 2. And voila, so you got your min and max. So you produce your sort of, now you're going to be producing your your dim, I guess. Oh, yeah, so your dims, that'll be a subtraction between your max and your min. But then you also got to add 1 because it's inclusive, which is the annoying thing about inclusive ranges. So yeah, the 1. Then, so that will get you basically, if it's the whole cluster is 4, then you need to scale it up into highest LOD space. So from your current LOD, wait a minute. It's a single cluster. So yeah, that's right. So you shift it and you return your dims. So that half dims. Cool. So I think that's the things that we want. So we can print these as well, which would be super nice. When we've done the sorting. But from here, when we plug into the ray tracer, we need to work out a center position. So we'll get the cluster coordinate like so, occluder, and then we'll get the half cluster half dims, if you will. Wait, I didn't divide it by 2. Div s. There you go. Half dims. So you put out the half dims. So we need to make a sort of like the center position. Now maybe we should just return dims, not half dims, and we'll do the division here. So we get dims out. So I want a center position and then half dims. So this is supposed to be dims. Good old regular set dims. So basically here we want to do a divide s float this time. Do a float cast it into a vector of float. So that would be your cluster dims, and we'll just divide that by 2. Then this center position is calculated by doing a sort of an add of the half dims onto the. So we add onto again another float times 3 cast of cluster coordinate this time with the cluster half dims, and that will land us. That'll get us a center position coordinate, which we can then plug into this code, which takes it into a signed norm space from -1 to 1. And then from here we do the ray tracing. Basically, we just do the ray tracing and render the occluders. Yeah, I just did the most easiest thing to implement, and with probably okay performance. We need to see how this code actually scales, but yeah. Anyway, so this should be right. We're going to be doing a sort of this in a minute. I just want to make sure that the new data that we've formatted is good. All right, and away we go. Okay, so it's still working. We're still getting our occluders. They're showing up in the occlusion buffer. So this is the occluders that we make for this guy. And this is the oh, my days, they're off. Ah, the y-axis is off. Why is the y-axis wrong? What would cause that? Where does the flip happen? And also, why didn't it happen before? Unless it was happening. But I don't know anymore. But yeah, if I just undid it for a minute just to see what we used to do. We used to just encode. We just added cluster chord and half dim. So we go back to that sort of volume occluder function. Quarter LOD is just that. I don't see any flipping going on. Maybe... we could probably undo the code, but that'll just be annoying. Yeah. Right, we do flip the wire when we write into the MIP texture. That's what we should do. Right? Maybe. Okay, this quote-unquote fixes the problem, but I don't know if it is the solution. Ah, because when we did the reprojection, yeah, that doesn't flip when it writes it into there. Yeah, we changed that logic. I think. No, the depth texture could be flipped though. Ah, damn these bottom left, top left origin things. Yeah, we write it into the depth texture unflipped. Yeah, so it's just inconsistent in that case. Good. So it wasn't because of the new stuff that we've done. Right. Good, 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 good. So now we're seeing this in here. As you can say, it's flickering because we're regenerating the occluders every frame and they end up being different. Yeah, so this is why we need to sort them. Okay. So now we're going to work on the sort code. So something I realized is that we don't need a payload for this, right? We've got the sort keys. The thing itself, the only thing, you only need like a key that you need to sort in this case, and not a payload as well. So I think we need to do two versions actually. So I need to look into that. Right, I'm just going to take a quick 2-minute break, and then we'll probably make two versions where you can do a payload version and a non-payload version as well. Right, BRB. Alright, hello everybody, welcome back. So what I've realized is that I would have to move it into an include file. Damn it. And then re-include and have different versions of shaders, and I don't want to do that. I've been asked to remove. Yeah, the Storm songs are pretty good. Like he's just a gem for as weird as he is, and for things that he says sometimes. He is a gem. How's it going, VMT? Yes, this does make more VGPRs. Just 4 more VGPRs. What's the problem with that? Yeah, I wanted to put if statements in here instead. Because why not? You know? There's not many places. So it's only in the final one. What I'm thinking about doing instead is just making them if statements. Terrible idea. Terrible. BC source payload. Wait. Source payloads. So if I cast that's an integer, that's a non-zero value. then we'll do this. Yeah. So, kind of not the best idea, but easiest thing we can do right now. It might eat a little bit of performance, but I don't know how much. Because it needs more VGPRs, but then the branches will always be taking the same on every invocation. So I don't know. It might be quite negligible. It also needs more LDS memory. So maybe that'll be quite bad because it will fit less on the be scheduled. Right. That ought to be good enough. So I reckon what we can do then is just do 2 versions of that. So sort, payload, with payload, and there'll just be one which only sorts keys. And then we can just simply truly a gem. Good. How's the sorting coming along? We're sorting it out. That's terrible. But yeah, we start off with a HCC bug, classic. Spear V is just a bit of a nightmare, but payload, that's it. But then what ended up happening after that? We've then tweaked a bit of the UI. So I've now got these 2 buttons here, so I can press escape and it untraps the mouse. Nice. And I can enable and disable the reprojection of depth from the previous frame and disable the occluders that render as well. So we can find these bugs basically. And I think I've thought of why it's flickering. I think it's because every frame, the spheres that get binned into the screen tiles, they are in a different order. And I've got some anti-aliasing code in the sphere ray tracer, which assumes that they're sorted from front to back, which I haven't got the sort code in there yet. And because I remember it carried over from when I used to have them sorted, so I uploaded them from the CPU. That's how old the code was. I haven't changed. But now we've got the new GPU sorting thing. We can actually, after we've got the occluders sorted and working, so they stop flickering here, because I'm rebuilding them every frame for debug purposes. Then we can actually probably sort out this flickering problem, which should then probably fix this, but I don't know. Maybe it won't. I got to figure out what the issue is still, I think, but maybe I'm onto something there. I don't know. They kind of go. Yeah, I'm a bit confused. And it's maybe earlying out when it hits a sphere. Oh, that's interesting. Is it doing that? How does this code even work? What did pass me do? If success, closest hit. Oh no, it just finds the closest hit and puts the depth in there. Right. And then it will do the anti-aliasing. You know what, maybe this isn't the thing causing the flickering. I don't know. Programming. So let's add there's 2 new lovely functions. We've got ones which don't support sorting payloads. These will pass in a null ID. But yeah, how's things going with VMT? You been up to much? GPU resource ID null, is that even a thing? No. Past me has not got current me's back. Oh. Core ID null GPU resource ID. Right, that works. Because we've got like an object pool, so it just puts in as it's basically just 0. It's a fancy way of saying 0. But anyway, that's the way it goes. Indirect. We need these boys in there. Right. So we're still not done because we need to make sure that if this payload is null, then problemo. Oh no. Do I have null IDs? I don't think I do. Yet. Oh wait, sorry. I'm thinking about something else, not what was just written in there. I'm questioning about when I do this sort of get index, resource ID to index. That function probably requires something to exist. So it's not like an optional check. GPU ID index. Oh, it just takes the index mask. Excellent. So we'll return 0 for the null ID. That's great. Amazing. But I think you can have a resource at index 0, but that one starts at counter 1 instead. But these resources will never be the ID, so it's fine. It's a bit of a hack though. Actually bit the bullet and abandoned. Yeah, maybe I should use a different sentinel value, but well. Actually bit the bullet and abandoned win UI 3 along with the win RT crap in favor of an immediate mode UI for some client work. Interesting. This is what you didn't want to do. I kind of wasted a few weeks on that when UI 3 is not feature complete and development on it is frozen. I got the business logic done and translating over the GUI is not a huge pain. Nice. Even though UI 3 is supposed to be the new way of doing Windows with C++. Yeah, they keep trying to replace their old windowing stuff, and then they basically fail every time. But I never knew that one existed. So what ImGUI did you go with in the end? And it is very easy just to whack stuff together with it. Shoot, what's the problem here? I gotta do a dot. Alright. Excellent. So, now, what we have is these sort functions which can work on just keys. Amazing. So if I look for sort, well, we had the other sort code, excellent. So here's the plan. We want to take the volume constructor occluders, sort those boys, and we're going to hard code a value. We'll do the indirect one in a bit. So we're going to put in the maximum ones to sort. So volume constructor occluders count. Oh, for crying out loud. Yeah, no, that should be fine. Problem is I'm not going to fill in all of the data, so we're going to get some invalid data probably. So does this get mem set to 0 or something? I need to make sure this gets cleared then. So where's the mem set? Yeah. Volume constructor occluders. Clear it to 0, please. Great, so now it won't sort those things to the front, I think. I'm not sure what order it is. So, wait, is this? Oh yeah, we'll do the sync code. Right, so there's the sort. So let's see if this crashes and fries my GPU. Dear McGee, forgive me, Father, for I have sinned. Or as you've been forgiven. It's pretty good to just to get some stuff together in GUI, and you can theme it as well. Yeah, there are a lot of. Whenever you want to do anything right aligned in MGUI, it's a pain in the butt. You basically have to just go full ham into the sort of manual positioning stuff. I've done plenty of MGUI stuff, and oh my days. There's also things to do with selecting different fonts as well, like scales of fonts and stuff. It's a bit weird. And yes, here's the other one. If you want a checkbox, which is on the left-hand side, if you want a lovely checkbox that's here with some text here in MGUI, you have to write your own little wrapper ones which do it, because by default, it is the other way around. It's just, yeah. So, but other than that, it's super great. I would much prefer to use it over anything else. If I just, yeah. They have no idea at Microsoft about how to proceed. You can obviously still use WinAPI for UIs, but then you have XAML islands plus WPF when UI2, when UI3, then Blazor is a mess. Oh, but they also had that they had another one, which they bought a company which done. Oh no, maybe that was their. They bought a company which ported WPF to mobile, I think. I forgot what it was called. Anyway, maybe. But yeah, there's another implementation of WPF. Yeah, Xamarin. That's it. That is it. Yeah. Yeah, hooked into the WinAPI DPI changes for notifications, rescaled the fonts to user request scaling changes. Yeah, I think the problem is like, if you want a different version of that font scaled, you have to sort of like, you can't, you have to have a completely separate font for titled text and body text, right? If you will. But yeah. And just bake all the resources into an executable with some assembly, some hardcore. Oh, I'm sure they have another one, but what's the point? I don't understand the big picture anymore. Yep. Maybe that's true. Right, let's see if the stream dies. Here we go. Right, stream's still alive. We crashed. Right, it's trying to do sync code on a null resource. That's why. So into the GPU backend we go. Where it does the sync resource. What we want to say is if res raw equals 0, do nothing. Okay, so let's see if we crash the GPU now. We're still alive, kinda. A bit wacky though. Like a random party going on. And I probably don't want to keep doing that because we might end up crashing the stream or something. But why the hell were these things taking so long? What was the Yeah, there's every now and then it's taking so long. So what was the culprit there? Oh, for crying out loud, it's still... Kill all of the game. Right, so let's find that 25 ms thing again. Here it is. So what was the bug? It was just taking so long. Was it this? Was it the parallel sort? No. Good. Draw 2D render. 11 milliseconds. That was weird. Right, so apparently it's the other thing. Oh. We're overflowing into the buffer. We must be. We must be overflowing into the buffer, which ends up... It must be what's going on. Yeah. Right, so when I run this, it's overflowing into the buffer, which ends up pushing on debug drawing shapes to the screen. Can you see those different debug drawing shapes that just appear? Right. What the crap? Let's make this value 4. Okay, so what's the occluders? Where are the debug draw 2D? So what are we doing any of that? That's when we do the out of bounds. Oh, what is that? If local space x greater than 1. And it does that when I render the occluders. Okay. So I think we're getting some null occluders or something in here. And then it's just trying to render those. Okay, so we should turn off the occluder ray tracer and just debug all the data out somehow. If you don't mind me asking, how are you planning to alpha blend and compute shaders? What are your performance implications for this? Yeah, no worries. So the plan right now is we're tile binning all of our spheres into tiles, right? So what we're going to be doing after this, we've got a nice sort function now, which is super fast apparently. So hopefully we're going to fill an array, massive array with all the spheres, and we're going to stick in the high bits the tile index, maybe. Or we'll have the keys be the tile index and the payload, which is in another array, and the payload, which is in another array, this will be the index to the sphere. So we fill all those up and then we sort them, and then we can have all of the spheres sorted. You probably want them sorted by tile then depth. So this is going to have tile and depth in it. This is the key, this is the value, where it has the index to the sphere in some sphere memory. And then we're going to sort these two massive arrays. And then this will define a boundary for where, because the tile index is in the high bits, essentially you're going to have arrays per tile now, all laid out and sorted front to back. And then we'll do front to back alpha blending while ray tracing. So we'll ray trace the spheres front to back, and we can early out when we get hit. And we can do anti-aliasing as well. All in that same thing. So that's the plan. We already are kind of doing it, just not that sorting thing, basically. Yeah, we've tested out the anti-aliasing before. I know it works. And it's pretty nice. But yeah, the problem with this method is that the more instances that you have, the more work it is. And also, that's why I've got the occlusion buffer. But the other thing is as well, is this only works for the main camera perspective. So if we want to do any other type of ray tracing like secondary bounces, we need some other kind of acceleration structure. And maybe building 2 acceleration structures is not a good idea, and maybe just one is fine. So we're seeing how good of an optimization this actually is. So we've got to build it though to find out. Yeah, I'm only rendering spheres, that's going to be the idea. We might make them ellipsoids. But yeah, spheres for now. See, I think, yeah, so if we disable the ray tracer, occluder's ray tracer, what I want to do instead is probably debug print all of the occluders. Oh yeah, I can just turn this thing to false. And to do that, when we do make persistent, where we take the thing we've constructed and make it put into persistent memory. In here, this is where we debug draw all of the occluders. So basically I want to turn that on. But what we debug print, what we're doing, we're debug printing the best occluders. Yes. So sort, they get sorted. So then we can remove the debug drawing stuff because that's not going to look good. And then we just got to fix all of this silliness. Center position snorm. Right. So I've got to... I don't know why I'm doing it that way. Right, so I think I want one of these. So let's get out the cluster coordinate and the dims. Let's just print this information. Cluster coord. So basically I just want to say occluder, really, and I want to say at this position, I want to say something like occluder number at, and then the sort of size, and probably the size would just be u multiplied by that, multiplied by that. Right, so we pulled that in. So I gotta think though, this is the... Right, it's just asking every thread to do it. Right, so you put your SV dispatch index, that'll get your element in the array. Then you want your cluster coordinate dot x, y, then z. Then you want to get all those dims. Then that ought to be good enough, I reckon. Yeah, the OOBB though is not going to be rendered, but we can do that. Wait, that wasn't even rendering any... Oh no, okay, yeah. Okay, good. Let's see what we get in the terminal. Let's look at our occluders. I could disable the performance thing and we could just see the data. But so what we're seeing is that they're not being sorted. Okay. There's that. They definitely look a bit scrambled. I can tell you that. So we should be seeing the biggest dimension. Yeah, we should be. And I guess this changes every frame, right? Yeah. Wait a minute. Did I not mem set it to 0 every frame? Oh yeah, mem sets every frame. Has built never gets set anymore. Yeah. Okay. Good. So. Right. Why is this sort then not working? What are we doing wrong? I guess the thing to look at first is what does it look like without the sort? Like it's going to be different every frame still, but the data, does it look okay? Because this data just doesn't look okay. How does it look without the sort? Does the data just look okay? So this looks like okay data, doesn't it? It's all like we're only doing full clusters as occluders, and this all just seems pretty okay. So when we sort it, it gets messed. So something is clearly wrong with the sort code, and I don't know why. So yeah, we've got to figure out what the problem is now that we we never set source payload. Oh, you only set it here. Destination payload. Okay. Right. So I guess we want to check this. So it's running something. It's definitely running. It's just one of the shaders is, yeah, something to the shaders is a bit messed still. Oh, this is going to be a bit of a bugger to find. So, right, let's go from the top of this sort of the sort function that we've ported over. So they set up the constants, right, and then they do this dispatch of its indirect. They set it to the input key buffer here, scratch key buffer, input payload, scratch payload. So we do something similar, right? We dispatch our setup for our non-indirect. So we set up our global variables. That all looks fine to me. then I wonder, we could have probably done this using the same GPU code, because when we do this setup non-indirect, it's just storing those in the globals. First of all, am I missing anything? The question. So I got 6 there and then 6 there, so that's correct. But yeah, I've basically ported that other code to GPU anyway here. This is for the indirect one. I might as well, like, just only pass up the sort count and have a function that's just shared. Because I've got it in CPU and GPU anyway. It might be a bit slower to do this. Or it will be slower. But yeah. Guess we can leave it. But yes, I'm sure that's okay. I guess we can double check that. That'll be in the parallel.h. There's something to do when you set up the push constants here. Right, so your num keys. Got your... Yeah, maybe there was like a rename that we did and it just got a bit buggered up. Let's just have a look around. But yeah, so that looks fine there. Block size, num blocks. Divide around up. Num keys and block size, yes. Num threads to run. It's divided by that. Yep. No additional blocks. Yes. If that's less than that, 1. Yes. Then yes. Then set up, take those 2 local variables, plug them into there. Then the number of reduced thread groups to run. I didn't change any of that, which is fine. Per bin. Scan values. Okay, good. So that's all fine. Then I'll just dispatch. We should check the... Yeah, we'll check the CPU source code for dispatching, and then we'll check the GPU source code and see what we've done wrong. So, sort keys. Right, I think I've got the same 2 guys open actually. Let's take it back. Oh no, that's different. That's the GPU one. Right. CPU side. So, right, input buffer, scratch, input buffer, scratch. Okay, good. So you start your shift off at 0. You have this sort of loop. I haven't changed that. That's fine. Then I do my sum. For the sum, yeah, you dispatch with num groups to run. But the yes, the sum count is called. Oh, why do they pass in an I? What am I? Have they got permutations for different? Did they do that? Crap. Did they do permutations or something? Seems annoying. Did I miss that? So iteration count. I want to see this. So for every parallel sort iteration count, need to create for each iteration as the resource views and constants are tied to the pipelines in the backend. Crash the memory associated to them. Where does I get passed in as some? Each iteration as resource views and constants are tied to the pipelines in the backends and cycling them with thrash the memory. Right, so there's no permutation for I. They've just done it because they're pushing the constants in there or something like that. This constant buffer or whatever. Something dumb like that. Alright, that's cool. That's just this variable here, which is fine. So sort scratch buffer is what it puts it into. That's the sum table and the keys, source keys. And it reads from the global res. Right, reduce pass, which is the reduced count to run. Reduce table is reduce scratch, and then the sum table is there. Okay. That seems fine. Then they've got the scan pass, which is just launching one of those. It says read write on the scratch. Oh, that needs to be the reduced scratch buffer. That's probably the issue. The reduced scratch buffer goes in here. So reduce scratch buffer. Then the next time it's just regular scratch buffer with the reduced in the scan scratch. Not confusing at all. And then right. Then what else have they got in here? Make sure I put the correct sync code. So just double check the rest of it. Scan add, scratch. Yeah, we're sorry, we already read that one. That's with the reduced again. Yes. Then the final one, which is the scatter. Right, source destination, sum table, and scratch. Yep. Payloads. We didn't sync on the scratch. That's not good. Okay. So I think those are probably the issues, but let's just double check. So let's re-enable the... Right, the sort code is enabled, so hopefully that works. Mr. Beast, what happened? What do you mean, Mr. Beast? What happened? What do you mean? And hey, welcome to the stream. Oh, we're not getting any problems now. This is good. So let's go to... Actually, no, sorry. That was too early to determine. Right, so we get a bunch of zeros in here. And then this. Right. What does this mean? Yeah, so it wasn't doing any debug drawing anyway. Is the default value 32, 32, 32? Some little bits of inconsistencies here. But what is... What would zeroed mean? Let's hard code that actually, and let's see what we would get. So where's the print code? Make persistent. And the make persistent, instead, we're just going to hard code .0 and see what we'll see if it's zeroed memory. I feel like it's still doing a sort of right, let's see what it would do there. It would put 32 in there. Why would it put 32 in there? Because you're at LOD 0 and you've got a 0 0 with a 1 sphere. Right, okay. So we're seeing the 0 data. So I think it actually sorts from high to low. Sorry, from low to high. Okay, it sorts from low to high. I think that's the problem. Now. So we could look at the end of the array. So we can grab it backwards, basically. So instead, you could do something like max, like you just grab it from the end of the array and you just do a reverse index, right? So instead, what happens if we did that take 1? What would happen? What do we see? Still a bunch of zeros. Right, here we see proper values, I think. Yeah, okay, so it's still not sorted at all correctly. This is not good. So I don't know if it sorts from low to high or high to low. So we'll figure that one out. So I guess we've inspected this CPU side and it seems okay now. We should also make sure we make those changes to the indirect version quickly. So the problem is this one needed to be the reduced, didn't it? This one here needed to be reduced. Then the other problem was the scratch wasn't synced on. Scratch wasn't synced on, was it? All right. So now let's take a look at the shader code for these guys. See what we can find that's wrong. So let's find the parallel sort. So we know that we're setting the shift correctly, I think, because it gets changed in that loop, right? Yeah. So we know that gets changed. That's fine. So here's the constants of the tables and that. So let's investigate. These are my silly functions which I shouldn't have done because they want you to provide these and I did provide them. I should have just inlined the code. But yeah, they come from the right things, right? So your source keys, load payloads, load sum table, load scan source, load scratch. Store key in the destination table, score payload. Store on the sum table, store on the juice table, and store scan des. What is scan juice? Right. There's a reduce table. Wait. When do we set that? Oh, here. All right. Good. Anyway, so this is the first one, the sum. So So the sum scatter pass. Right, sum pass. Is this the first one you call? Number of threads is all fine. Right, just local ID and group ID. No biggie. Alright, so let's double check this code. So there's like a histogram. Yeah, local ID, group ID. Like a histogram that gets built. There's a barrier. Block size. Num. Okay, so these are stuff that could be wrong because I maybe went a bit too fast when looking at these. But yeah, so I guess let's check the code that sets these first. Num keys, num blocks per thread group, num thread groups, yep, num with additional blocks, yep. Reduce, yep. Awesome, so they're fine. So back to here again, what I was looking at. So num blocks per thread group, yep. Num thread groups, yep. With additional blocks and sort entries. Excellent. That's all cool. Right, so I'm wondering what I ended up changing in this. Probably this got changed a bit. Just added a BC prefix. There's an atomic add. But that's all fine, I think. Should be alright. Then there's store sum. That should be fine as well. Alright, so that one looks alright. Let's look at the reduce. The reduced has a different entry point. It's in reduce count. So this one did get changed. I had to use my own intrinsics. So it does an active sum on the local sum. Then it gets the wave ID, which is that divided by get lane count. Yeah. Is first lane. We added this. Active sum. That should be pretty legit. Right. Num reduce thread group, num thread groups. Yes. We didn't change anything in here. Really. Okay. So this one was a heavy change as well, because it's either HLSL or GLSL. So we had to port it. So there's a prefix sum. Oh, that's a problem. Get lane index. No, no, no. Do we have that function? Right, that was an issue. Third party HCC libhcc intrinsics wave intrinsics thread index. I think we have it. Pretty sure. No, maybe not. Maybe we're not sure anymore. Yeah, I don't think we have this. We can add it in. But yeah, we need a way to get the thread index. You can get this manually in other ways, but I guess it is useful. So for that, Yeah, I need to put it in the, right, let's do another HCC patch. So we grep for is first lane. Find all the places we can make all those changes. So I want to go to HCC first. So this would be thread index, then thread index. So we added an abstract machine language operation and a new function, a new intrinsic function. So I need to go to the header file, and then need to find that is first thing in here, and we'll add that thread index. Let's be 32. Returns the index of the current thread within a wave. Kind of self-explanatory, but anyway. Hey there, Master Agent. How's it going? How's it going? How you been? Thread index, that's what I want. So this is just used for when we debug print the abstract machine language. So it's got a string for the instruction name. Then this one is simply saying, does it have a return value? Yes, it does. Because we don't have any type information about the intrinsic stuff. We just want to know if there's a return type so it can sort that out. Programming, lots and lots of programming. Yes, my friend. This is the way. But yeah, how's that little project coming along? That you're doing, that you put on your GitHub, right? How's it coming along? Then we need to add this in the abstract machine language, nice. Then in the abstract machine language generation, we need to actually generate this type. So from the intrinsic function, we're going to translate that to the intrinsic instruction, right? So from a function to an instruction. Then we need to translate. We need to go into core still and give it a name actually. Then we need to translate into SpearV. Thread IDX. Cool. So that's again for debugging, and I think for actually parsing it in the header file and be like, oh, this thing has a definition already because it's an intrinsic, stuff like that. So then in the SpearV gen, we need to do another one of these guys. So this is wave thread index. We need to figure out what that operation is. So let's just figure out. Let's ask HLSL what it does. Get lane index, and we will be given the thing. So the thing we need is subgroup local invocation ID. Damn it. It's even worse. So there needs to be a global variable. Damn it. Why? And then you load from the global variable. and then that global variable is of input, and then you need to tell it that it's one of those built-ins. Yes. Right. We got this. Honestly, at this rate, I think I'll have a fully working game demo of the open source base within the week, and a full game up on Steam within a couple of months from now. Cool. Very nice. Funny thing, my New Year's resolution was to release a project of my own on Steam within 6 months. Mark of the year. But I had a specific project in mind. Which was stored. Ah. Right, so you're actually going to come and meet that. That's great. That's really great. It's really awesome. What sort of game is it? Like a genre? So I need to find these damn... how do we do one of these? I've done one of them before. Obviously. I've got like frag chord and all that crap. So I need to find out where I sort of do those. So I'm going to find frag chord, for example. Already it's like a system value, isn't it? Oh yeah. So we need to add a new one of those. 41. You need ballot. You need ballot or group non-uniform. I don't know these things. But yeah, subgroup local. What was that? 41. Subgroup, which means wave in 41. So we've got this now. Enum in there, which is great. So what else we're looking for record? Right, I need a new variable. Then, so this will be the I guess I would call it subgroup whatever. There you go. Okay, so in the SPIVy link, we set this guy up. So I copy this code here. I need a decorate to say what built-in type it actually is. I'll say it's a built-in basically. I'll stick it down here. So this is a built-in for it's the variable ID subgroup local whatever. It's a built-in for subgroup local whatever. Now I need to actually make this variable still, so we'll follow this around. So here's the variable declaration in the SPIVy file. This one is again for that variable subgroup whatever, right, local ID, and it's an input variable and it's of type U32 type ID. There we go. So I think that's all we need to do. We just gotta, yeah, good. We're in the generation, we just gotta load from that variable. So I think we've done a frag chord thing here. Right. So here you trigger this found variable, I think. Say like, oh yeah, we found this. Just stick it in the, like, only put it in the binary if we need it, basically. Wait. But then surely it wouldn't. It's putting it in here anyway, it's hard coding it. I'm confused. Why did you do a found global? What does that do again? Unique globals. Do I use that anywhere? Yeah, I don't know if that's needed anymore because it seems like we hard code it here. I don't know. Let's just put it there anyway. So now we just need to produce a load. So we've done one of these many times. Spear the upload. So we've got to find where we load from the So it did it in the frag chord, I think. Built-in variable ID. And we must have done a load before on that or something. Access chain. Right, there's no load. Right, let's just find that SPIV load thing. We'll just get it done. Right, so you just plop this in here. So we're going to load. Where we're loading from? Well, we're loading from this SPIV ID, which has been hard coded from the get-go, which is this variable. We're putting it in this result ID, which is this one here. So operand 0 is the return operand. So it's the return register. And then what is the intermediate? What? Oh, wait. Sorry. Shoot. This needs to be the data type we're returning. So I need a U32. I could just do the return data type. Translate the operand's data type. Yes, this is return data type. So return data type goes there. The return ID goes there, and the thing that we're reading from goes there. So that should be what we need to add that into HCC. So there's a U32. Whoops, U32T. Yeah, that's the C name for it. Right, that seems like it compiles. Let's go ahead and do a release build, so it's super quick and nice to use. We need to grab two things now. From HCC, I need the executable, and then I also need the new intrinsic wave intrinsics header. Pop that in there, and away we go. So now we've got this new lovely thing, wave thread index. We can just throw that into here. Bum, bum, bum. So that was one of the problems. So I think we've maybe got another one of those somewhere. Excuse me. This one is an RTS/builder. The one the resolution initially intended was for an adventure game, right? With physical simulations and strand beasts as main means of transport, right? But I had a hard time come up with what else to do with it, so it's stored. Okay. For the RTS is I have much clearer image in my head of the game loop. It's possibly why I could crank it out so fast. Awesome. That's nice. Yeah, I guess with an RTS as well, it's just a bit easier to it's top down, isn't it? It's usually they're like a walled environment, if you will. Not too crazy. Yeah, sounds like fun. Yes, let's carry on. So that was a good find. What else did we bugger up? So if it's the final one, right? Last element. Cool. Prefix sum, yep. Okay, that's the GSL version, which we obviously didn't worry about. So scan prefix, we didn't change any of this. We didn't change any of that either. Keep going. Yeah, seems pretty fine. Right, none of that got changed. Right, scan add. This is where it gets a bit different. That's the scatter one already. Okay, I need to double check these entry points. So scan add. Pass. Calls a scan add function. Man, I hate this thing. It's just so all over the place. Right, here we go. Thread groups per reduce thread groups per bin, yes. Thread groups. Reduce thread groups per bin. Thread groups. Okay. That seems fine. Good, good, good. So the scan version is just local ID 0 base index. False. Cool, cool, cool. That's legit. So the final shader is the scatter, and then we can give it a try, and hopefully it does the sorting. So let's just double check all these boys. So gotta go back into here. So it's the scatter. Cool. So yeah, num blocks per thread group. Yes, 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 and yes. Okay, that's good. That's all that I changed. The rest here has not changed. The rest here has not really changed either. I put these if statements around here for the payload values if you, rather than being compiled out, because I don't do shaded permutations just yet. I don't think there was any, see here there were just if defs, but anyway. Right, here's a HLSLE thingy. So I gotta make sure that's a prefix sum. Right, it's a prefix sum, good, good, good. And there we go. Right. So let's try this out now. So hit compile. No. Is not a data type. Okay, so we messed something up on the thing, but not to worry. Easily fixable. And we added this feature. I didn't convert this into the SPIR-V data type. Easy mistake. So I got my own HTC data type. I didn't convert to the SPIR-V data type. That was a problem. So I'm just going to hit compile again and then copy those exes. And I close the windows like a melon. So let's change that one over. Cool, 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 cool. So if we try and compile that, now I'll compile. So hopefully this works. Hopefully we get some sorted data now. No, it's actually not. It's actually different. So the group ID is the group, right? Is your dispatch group or your thread group, right? So basically, right, GPUs have 32 threads. Imagine this is 32 threads, right? They're running lockstep. So each one of these is a thread, imagine. within, like this would be a lane index of 5, right? Whereas this is a whole group, maybe, right? Your groups can actually be bigger than 32 because there's subgroups. So they're waves. Waves are subgroups. Groups are things that you specify here. So this is like, I think it's 1024. So I've got 1024 threads within a single group. And they're multiples of 32 subgroups, typically. That's what the hardware typically is. So the group ID is which group number am I, right, of 1024 threads. So when you dispatch your shader, you dispatch a number of groups. So you say, right, this does 1024 threads within a group. And you can say, okay, well, I need 5 groups. Oh, sorry, maybe I need 4 groups because I need 4,096 elements to be processed. And so this group index will go from 0 to 3. Right. So yes, that's the difference. All right. Here we go. So let's take a look at the data. It's still wrong, maybe. Yeah. One is we mem set it to 0. It's still a bit wrong. Hmm. This is quite difficult to debug as well. Because I don't know what... Maybe we got to debug like what the shaders are supposed to do. So this one is meant to count. So it does a sort of like sum. I've got printing, so I can do that. Yeah, it all seems pretty fun in that regard. It's just right into LDS. But yeah, I think what we've got to do next is we've got to figure out like we've got to run each of these shaders one by one and test the output and see if it is the desired output given the input or something like that. So when it's in this sort of sum, I got to figure out what the shader does, and then like, so we load the keys in. The problem is it does it bits at a time. And it gets 4 bits at a time. And then it will like actually sort those later in the scatter pass. Yeah, in the scatter pass. Where it loads the keys in. Figures out where they go. then reorders them. Very difficult to debug. But yeah, I think we can do one shader at a time. Should be possible. Right, I've got to think about this. Okay. So we'll, next stream, I guess, we're gonna take a look at each of these shaders one by one and see, because we've got printing, right? It should be quite easy. We can print out all the data we want. And we'll figure out where the problem is by just seeing what the input and output is. So we're doing that on Thursday at 6:30 p.m. GMT +1. But yeah, unfortunately, I gotta go now because it's getting late, and I gotta go into work tomorrow. So I actually have to be up even earlier, and I'm kind of late. So right, let's find someone to raid quickly, and then we'll yeah, say our goodbyes. Right, let's raid the Jagger. Alright guys, have a good Wednesday. Have a good Thursday. I'll see you all on Thursday, hopefully. And we'll continue on this sort GPU sort algorithm stuff. Because we really need a good sort algorithm. So hopefully that all works out. Next stream, hopefully. But yeah, have a good one. Catch you later.